Alright, so basically I'm trying to give you an explanation for how to interpret your gel filtration data from class. Alright, so what you want to do, so what I gave you in one of the Word documents was basically the elution volume of these size peaks from the standard protein mixture that we ran over the column. All right, now, so for the molecular weight, what we're going to plot down here on this graph is we're going to plot the logarithm of the molecular weight on the x-axis here, and the y-axis, something called K-av. All right, now, to make the log of the molecular weight, you just take the logarithm of each of these molecular weights, and that gives you the x values. All right, now, for the y values, the K-avs, there's a formula in the Word document you're going to have to use. It's VE minus V0 over VT minus V0. Now, I give you also, again in that Word document, VT and V0, which are the total volume of the column and the void volume of the column respectively. But the VE is going to change for each peak. That's the elution volume of each peak. So the VE values are contained in the table of elution volumes for each peak. All right, so what I've done here is I've gone through and calculated the K-av values for each one of these peaks. And then I basically highlighted both of these and went up to insert and did a scatter plot like this. All right, so once you've made a scatter plot, actually I'll do that real quick. Once you've made a scatter plot like this, it's helpful to be aware which axis is which. I would like you guys to go through and put in titles for your axes. So you can do that by going over here, horizontal axis, vertical axis, right? I'm not going to do that though. So now you need to add a trend line. Now the way you do this is by clicking on one of the data points and then right-clicking on it. And down here you have this option to add trend line. So this is basically going to try to draw the best straight line through your data. And we wanted to display the equation on the chart, and I would recommend showing the r-squared value. It gives you an idea of how well your data fits to that line. And we can close this, and here's our equation with the r-squared value. Now, I'm going to make up a peak elution. So I gave you guys also for each group the elution volume for your sample. So what we're going to do with this is based on the elution volume of your sample. So this 36 down here is one that I'm just making up. All right, you're going to first calculate a K-av value for that, which will give you your Y value. Now, once you know the Y value, you're going to use this equation to determine what the X value is that corresponds to that. All right. So in this case, with 36, I get a K-av of 0.08621. All right. Which I can see is going to be somewhere down here, right? But I can't. It's kind of hard to tell exactly what the X value is. That's why we use the equation. So what I'm going to do is take the K-av value. In my case, my K-av is my y-axis, so I'll plug it in for y into this equation here. And then I'm going to solve for x by just doing some algebra, and I get an x value of 5.91274. Now, all right, now that doesn't look like a molecular weight, but remember, x-axis is the logarithm of the molecular weight. So I'm going to take 10 to this power, and that gives me now the actual molecular weight of a protein that would have eluted at 36 mils. And that is it for how to interpret the gel filtration data.